know it's like, whoa.
Hello guys, welcome back to our YouTube channel Algorithm Pod. My name is Jitesh. So here I am with the next video of our series Cryptography and Network Security. So in this video we will be seeing IDEA algorithm. So in IDEA stands for International Data Encryption Algorithm. So it is basically an encryption algorithm. So any other encryption algorithm says to process of convert plain text to ciphertext. So in this we have a plain text. We can have a plain text of size 64 bits and the key size is of 128 bits, and we have total 17 rounds in it. Now here there is a little detail in the IDEA algorithm. The odd numbered rounds such as 1, 3, 5, such like this makes use of 4 keys to perform the encryption, and even number of rounds makes use of 2 keys. So let's see how this algorithm works with the help of a diagram. So as I said earlier, we have total number of 17 rounds. Now we have plain text of 64 bits split into the 4 different blocks. So we have a plain text of 64 bits with 16 bits each. Now this plain text goes for the rounds. So from the starting of round 1, it is odd, so it is odd numbered round, so it makes use of 4 keys to perform an encryption operation. How this what happens in the each and every round, I will show in the further upcoming steps. Now in the second round, even numbered round, it makes use of 2 keys, and these keys are generated with the help of key transformation algorithm. The key size will be 128 bits, and from this 128 bits the sub keys are generated. Total we can have a 52 keys. 52 different sub keys are used at each and every round to perform encryption, and then after end of the final round we can obtain the ciphertext. Now I will tell you in detail what happens in each and every rounds. For even number of rounds, what happens at even number of rounds, and then odd number of rounds. Now these are the round operations. So as I said, in odd number of rounds we use 4 keys to perform encryption. So this is our plain text of 64 bits split into 4 blocks of 16 bits each. Now these are some terminology. Plus if add, this symbol represents XOR and this represents the multiplication operator. Now each block is processed individually with the help of these 4 keys. Now take a look at this corner. Observe the corners first. Now we have XA, which is performing the multiplication operator with KA. These are combined to produce the output, and the XD combined with KD to produce the final output. This is plain and simple. Now take a look at this. Now XB is performing an X operation with KB, and the output of this operation is stored as XC, and the output of this XC and KC is stored as XB. In order to increase the complexity, we do this swapping operation. Now what will be the final output? We have obtained this thing, and the final output will be the XOR operation between these 4 and these keys. If we perform the final operation, we will get another new kind of block, a fresh block of ciphertext with a new different values, and this thing is passed for next round for further processing. This was about odd number of rounds. Now coming to even number of rounds. As I said earlier, the plain text is divided into 4 different blocks, right? Now even number of rounds makes use of 2 keys. Now this, for even number of rounds, there is a function called Mangler function, which helps in combining this plain text and performing operations with the help of 2 keys. Now at first XA and XB blocks are combined together to form the y in. Y in represents the input of the first portion. XB, XC and XD are combined and the output is represented as Z in. This represents the second portion. Now on this thing, the operation is performed. Similar operation in the previous step with the help of these two keys are performed with the help of Mangler function, and this function generates the output in the form of y out and z out. This will represents the output. Now how can we obtain our final output? We need to obtain a ciphertext, a new block with new values. So we can obtain like this. Now XA will be XA XOR y out. This XA will be performing an XOR operation with this one y out, and this XB will be performing an XOR operations with y out. This XC will be performing XOR operation with Z out, and XD is performing XOR operation with Z out. These are the, in this way we can obtain our new cipher, our new block, a new block with new values, and I mean updated values. So this is what happens at the end of even and odd rounds. This process continues until all the rounds are finished. After all the rounds are finished, we will obtain our ciphertext. So that's it guys for this video. Thank you so much for watching this video. Make sure to hit the like button, hit the subscribe button, make sure to hit the bell icon. See you guys in next video.